The client for this third study is a global manufacturer of food packaging solutions. They were interested in improving the existing raw materials inventory and management system for raw materials stored within silos. The legacy system utilized Plumbob level sensors in conjunction with the vendor's proprietary software. The client wanted greater visibility for supervisors and operators, as well as to collect relevant information in a historical database for report generation and compliance needs. The existing system exhibited several challenges. Operators manually checked the level using the Plumbob sensors located near each silo. This software did not report any levels back to any outside systems, and the manual nature of this limited the number of checks that were done per day, so there were no real-time updates. Because there were no external monitoring of levels, there were also no alerts generated for things such as low level. And receipt of raw materials was done through paper forms. These forms did not allow error checking to catch things such as unloading into the incorrect silo. Errors such as these were very costly for the company and were not rare. The goals of the project were first to go paperless. Currently, if they had to recall a rail car, for example, they would have to go through a load of paperwork to manually track the lineage. If they were to go paperless, they would be able to track that much easier. And then mobile access and future functionality that a digital infrastructure could provide was also of interest to them. They also wanted more accountability. They wanted to know who was working in the system and executing unloads, transfers, etc. And then they wanted a better defined overall workflow. The digital solution would give people the ability to execute documented workflows instead of relying on one person to do it correctly. So the new silo monitoring system utilized existing level sensor technology and interfaced using Modbus RTU and other hardware interfaces. The gateway communicates to the Polytron Silo Monitor application via Plant Ethernet, and installation could be done on a standalone server or a VM. Operator access to the system via mobile tablets using wireless access or at the unload stations or from areas inside the plant. Supervisors had continuous visibility via 48-inch dashboards, as well as access from any desktop computer around the plant. They had 10 concurrent user licenses available, and the data was stored in a SQL database and was available for management queries and reports. So let's take a look at a few pieces of the solution. On the slide here, you'll see the first piece is the silo overview screen. This is a dashboard that provides real-time visibility for all plant silo inventory. Each tile here represents a silo and contains important information such as the current material type, the pounds of product, the current status, and even has a color indicator that shows what the current volume is and if there are any alerts such as low volume. Another piece is the mapping screen for the bins. This allowed the operator to link the silo to specific bins for material transfer. Note that this is a user-initiated function in the current installation, but it does represent the physical configuration in the plant. This function was used to provide a tracking record for the assignment of materials to specific bins and extruder lines. This was very important in the event that a detailed tracing was needed, such as a recall. The next piece is the trail and rail car unloading screen. Each unloading location is represented by a tile on this screen. So for each rail location, there's also a column for each compartment, and that would be the bottom part of the screen there. The current status of each location is shown on the tile, including whether it's in use using color coding, the material that is being unloaded, the target silo that is being filled, and which pump system is being used, if any. Operators can check on a tile to fill, or can click on a tile to fill out the unload form or to mark an unload form that is in process as completed. As part of this form, there are also several rules that provide error checking. These rules assist the operator by avoiding accidental material mixing and also showing them which pump systems are currently available to use. And to conclude, let's take a look at the results. The digital platform has demonstrated value to the plant management and users since installation and has enhanced daily operations as well as access for compliance needs. The solution also addresses the need for reporting. All transactions and user interactions are captured in a SQL database and are available for management for reporting functions, and information is available in filterable reports from any system-wide computer. These reports can also be printed or exported to standard formats such as Excel or PDF. And the client has also expressed interest in future enhancements to this system. They may want to do things such as include photo capture of bill of ladings and certificate of authenticities for digital record keeping, add error checking between bill of lading amounts and actual quantities unloaded, and then additional tracking of rail car times at the site to avoid fees.